Welcome all. Example 1. Find the annual premium for a whole life assurance policy issued to a life aged 30, presently 30, if the sum assured is given 50,000 and is payable at the end of year of death of the policyholder. This is a very simple question. We know it. We write AM92 ultimate mortality. Remember, an interest rate is given 4% per annum. Okay. So using these two, we'll try to solve. So what you need to observe, AM92 ultimate mortality and interest 4% per annum. And the sum assured is 50,000 and present age is 30. So let me write here equation of value. Expected present value of income. Okay. Expected present value of income is equal to P only, one time premium. We are talking about one time premium here. And expected present value of outgo here 50,000. If the sum assured is 1, it should be A30, but the sum assured is 50,000. Okay, so we have to write 50,000 A30. Let me write here properly. So P should be equal to 50,000 A30. P is equal to 50,000 A30. For that, you need to see the table. Here for age 30 at 4% interest, this is 0.16023. Let me write 0.16023. Here 0.1602, sorry, 023 here, 50,000. 80115. Okay, 50,000. So it will be, you divide it by 10. This will be the answer, 8011.5. So here pay around 8,000, and whenever you die, if you are age 30, you will get 50,000 and you will get at the end of year of death. This is also there. Remember this one, end of year of death. This one. These are the things you need to observe in a question. So this is the one time premium. If you do it for annual premium, equation of value will be, let me tell you, we write P here and 50,000 A30. Here we have to write an annuity. This annuity will come. But you have to know what is that annuity, right? So we'll not discuss that one here. So this is over. Now the next question, if you see one time premium for a term assurance here, find the one time premium for a term assurance policy of term 20 years issued to a life aged 40. So this one will mark 40 here and 20 here, term 20 here, and 80,000 here, AM92 6%. Okay, so let me write the equation of value. P is equal to always
80,000 into A 40
20. Okay, that's
and
all.
one.
And one here. Okay, so how to get this one? Any idea? Remember, the term values are not listed in the actuarial table. The term assurance values are not listed in the actuarial table. So there is no way you can see the table and find this. Then how can you do this one? Yeah.
Sir, A20, A40.
Yeah, A40. What is AXN? That is A.
So that endowment minus the pure policy, we should subtract that.
Yes. Okay. So you are saying I should write A4020. Then you need to write A4020. Right? This
Yes,
way.
sir.
Okay. So where you get A4020?
In the table, sir.
Okay. How about the second term? A4020. Okay. So we'll see this one. A4020 is available because 40 plus 20, if you find, that is 60. If X plus N is 60 or 65, that is available. Okay. Suppose here you want to see for 40 here, X is 40 and automatically n will be 20. I'll show you here. N is 60 minus 40. That means if I've taken the age here 40, then n will be 60 minus 40, that will be 20. Automatically this will be 20. And remember, whenever x plus n is 60, you can see the table. Here we'll see the last but one column, okay, axn. For x40, you need not worry about n will be automatically 20. If I ask you x40 and n30, you will not be able to use the table. So you need to know, you see here 40 value, this is 40, 0.46433 minus, you have to find A4021 here, okay. When you find A4021 here, there is a direct formula. There is a direct formula for this term, okay. So what is that? Axn, just remember now, we'll discuss later. Axn is Pxn Vn, okay, you remember that. Pxn Vn, this will be P4020 V20. You need to use a calculator. This one you have to see the table 1 second, okay. So let me write it. 80,000, you write 0.46433 minus this one, L60 divided by L40. You have to see L table, okay. Then B is given, interest rate is given here 6%. So using 6%, you can find this one, 1.06 power minus 20, and then that will be equal to 80,000 multiplied by 0.46433 minus L40, L60. You have to see L table, okay. L table will be here initially. QX, DX, LX here. L60 divided by L40. So if you see 60 here, this is 92872164, 1.06 power, 1.06 power minus 20 power minus 20, okay, 0.311804. Now this is your task, okay. You find P, whatever it is, that will be the answer. Will not worry about this calculation here. This is example 3, okay. This is term assurance, term 3 years, 40, 80,000, M92 ultimate, 6% interest rate, payable at the end of year of death. This one also you need to mark, okay. Then you write the equation of value. So 80,000 is not changed from last problem. We change the term here. The term is 3, okay. So let me write present value of income, that is P always here. In this case, it will not change. And this one is 80,000. Now it's 3 years, okay, only 3. But remember, if the term is 3 years, then you will not be able to see the table. You will be able to see the table only when x plus n is 60 or 65. Remember, if you want to see the table for this one, this is available when x plus n is either 60 or 65, only for these two values. That means you will be able to find A4020, because 40 plus 20 is 60. You will be able to see the table and find the value for 25 also. If I write A30, for 30 it's available, 35 also available, but this is not available. I mean, if I want to see A43, this is not available. If this is not available, then you will not be able to find this one from the table. We will not worry about the pure endowment term. So if this is not available, then how can you do? That is the question, okay. See the question, 6% is given. So still we can use mortality table, because if you want to see the mortality table, actuarial table, the interest rate should be either 4% or 6%, and mortality M92 or some other table, okay. We'll come across that later. Still you will be able to see the table, but here x plus n is not 60 or 65. So if x plus n is not 60 or 65, there is another formula. Okay, I'm writing here. Just remember, we'll derive that formula. This is one formula. AXN1. This is for the term assurance. The formula is AX minus PXN VN AX plus N. Okay, this is the formula. So this formula you can use and you can find the value. Suppose here we have this one. P is equal to 80,000. Here you write AX, that is A40, minus PXN 43 V3 A43. Okay, so now if you want to find its value 80,000, this one, see the table. Okay, this one you get from the table, this one you get from the table. V you can get from 6%, 1.06 power minus 3, and this one you can use L table, L43 divided by L40. So once you know this, then you multiply with this one, you will get this answer. That's all. So remember this formula. We'll do in the next time, next class. This is a formula you need to remember now. This formula. You might ask a question, when you should use this formula. Okay, you should use this formula when x plus n is not 60 or 65. If it's 60 or 65, you can directly get from the table. That will be easier. However, if you want to use this formula and you have a term assurance, remember the formula is for the term assurance, not for endowment assurance. Like in this case also, if you don't want to use the table, because directly you get the answer here, and this one, for this one there is a formula. Okay, you get it. Maybe it's a bit easier because you know already one term from the table and one term you are finding. So if x plus n is 60 or 65, you can do this way. However, if x plus n is not 60 or 65, here 40 plus 3 is 43. So you can see the table to find this value. In that case, you should use this formula. If you want, you can use this formula all the time, irrespective of when x plus n is 60 or 65 or not. This formula is true for all values of x and n. You need not worry. Now, again, let me tell you that we are in the very initial stage. Don't think that these are the questions you will get in the exam. In a question, you have to find these things 4 to 5 times. So what will happen is time will be very important. So within the time frame, if you want to solve an equation, you have to find all the easy ways. Okay, so if you can save time 1 minute or 2 minutes by some method as compared to some another method, then definitely you need to do by the formal method. Okay, so that is very important. Here one time premium, that's fine. In the left hand side it will not change, it's one time premium. So this is there. Term 3 years, this is 40 year, and this is 80,000. Okay, sum assured is given 5%. If interest rate is 5%, you will not be able to see and find the value from the table because interest rate is 5%. Remember, you can see the table and find the value only when interest rate is 4% or 6%. Here 5% given, so we'll not be able to find that from the table. Okay, so if I write equation of value and expected present value of income, I'll write P here, and then expected present value of outgo, this is 80,000, and then I have to write 43. Okay, it's term A43, but we can see the table. If you compare with the last problem, we use the table anyway to find the value A40 and A43. Then for this one also you need L. Okay, L you can see the table because here this will be L43 divided by L40. We don't need any interest rate to find L's. Okay, you need interest rate for this one and this one. So you can't use this formula. You can't use this formula. You can use the formula, but you will not get the values for A40 and A43. Okay, so although you can use the formula, you can see the values. There is no way here for you. So you have to use the general reasoning. You have to do it directly. And remember, this kind of a question is there. This is only for your development. Remember, at 5%, you can never use table. So what you can do is you have to find directly. If you remember, this is A43 term. Let me expand let me expand it, okay, 80,000, and I will write here the first term, that is Q40V, and the second term with this probability Q41 P41 Q41 V square, okay, and the third term is P42 Q42 V power 3. These are the terms, okay. Three terms should be there because here this is a term assurance. Then Q40 you can get from the table, you need not to worry. This is available in the table, okay, directly. This one you can use L table, you can find it L41 divided by L40. This one you can see the table, you can find L42 divided by L40. This one also directly in the table, this one is also in the table. So you need to find V, that is 1 upon 1 plus 5, that will be this one, and this one 1 upon 1.05 square, this one will be 1 upon 1.05 power 3. So you can find this way. However, if I give it for 30 years, there will be problem. You don't have time. Even if you are not appearing an exam, you can spend this much of time, okay. It's not available in the table. If it's 5% or 7% or 10% or 2% interest rate, then you can't find these term assurance values, okay. It will be given only for 2 or 3. Even you will not get these kind of questions, but you have to know what you can do and what you can do, okay. That is very important. Then the next one, find the one-time premium once again. Endowment policy now, term 3 years, age 40 present age is 40, sum assured is 80,000, okay, and the benefit is payable at the end of year of death of the policyholder. When we say endowment, there is a survival benefit also. Sometimes you will get in the question, or here I can add, or survival to the end of the term. Even if this is not given, if endowment policy is written, remember two types of benefits are there. One is the term benefit, you can say death benefit, and the other one is survival benefit, that is called endowment benefit, okay. 40 years. So write the formula 43 80,000, okay. 4% M92, you need to remember. P is equal to 80,000 A43. Again, you will not see this from the table. You will not get the value from the table, because if A, X, N you want to see from the table, make it sure that X plus N is either 60 or 65. It's not 60 or 65. So this is not available in the table. So what you can do is you divide this one into term 1 and pure endowment, okay. So let me write this way, A43 1 here plus A43 1 here, this way. Then you write P here, 80,000 here, and this one you can do this way, 4%, right? See, this formula you can use and you can find the value. So let me write it here, A40 minus P43 V3 A43, okay. So all these things you can get in the table, plus there is a direct formula for this one, P43 V3. So you can find everything from the table, and this will be your final answer, okay. Next question. This is one-time premium, endowment, term 3 years, age 40, benefit 80,000. All things are same, okay. Payable at the end of year of death, everything is there. M92, but here 5%. That means if you compare with the last question, even you can't get these things from the table, because 5%, at 5% you will not get A40 or A43, okay. If M92 is given, then you can find P43 but not A40. So for that you have to do it directly. So let me write P is equal to 80,000 A43, okay. So you have to find it directly. So if you want to find it directly, let me write another line here, A43, already we know this. Okay, so let me write the expression for this one. A43, that is Q40 plus P41, the first one, Q41V plus P42 Q42V square. These are the term, and there is a last one, endowment, A43 1 here. For that you need to write P43 V3. So here there is a death benefit of 1. When you multiply 80,000, there is a death benefit of 40,000 this way. This is the first year. The person is fit and fine here. Age is 40 now. If this guy dies here, there is a benefit here. Okay. So the present value of the benefit you need to find. That will write here Q40V. Then V square. You have to write V power 3 here. So if the person dies here, benefit here. Okay. If the person dies here, there is a benefit here. Even if the person survives, there is a benefit. Okay. Surviving for 3 years, the probability is this. With this probability, the present value of the benefit you are finding, that is V power 3. This is the probability, this is the benefit. Okay, 80,000. This is the discounted value, V power 3. So using logic also, general reasoning, you should know how you get it. Okay. Let me check that one, how I've written. Yeah, this is fine here, no problem. These are the questions. So yeah, you make it proper.
So it is the probability that a person aged 42 will live for 3 years, survive for 3 years, and die the next year.
Okay. But still it's not final. There is something else you can say. However, you are almost correct. Okay. So you are saying 3 to 4 years. So when you say the person will die between this, there is no guarantee. Okay.
Is it the probability? What is the probability of a person?
Exactly. What is the probability that this will happen?
Person who is 42 to live till 45.
45 and die within 46. That is also correct, but we are finding the probability. Okay. The probability that this will happen. Okay. Now, tell me something. K40 less than 2. This means what?
The person aged 40 will survive for less than 2 years.
Okay.
What is the probability that the person aged 40 will die within 2 years?
Die within 2 years, right? K40 is less than 2. K40 is equal to 2 means?
That means survive.
Okay, 2 years.
Survival of a person.
2 years survival, right?
Yes.
Okay. So this means this one. Okay. 343. So this means this one, that's fine. How about this? Suppose I say this one less than 2, K40 less than 2, and I will write another one, K40 greater than 2. K40 greater than 2 means presently this guy is 40 and K40 means presently 40, that will be greater than 2. That means K40 is equal to 3, K40 is equal to 4, all the cases. K43 means dying here, K44 means dying here. So that means what is the probability that the person will die after this, either here or here or here, this one. Now let's check this one. K40 greater than 2, K40 less than 2. Okay, K40 less than 2 means K40 is equal to 0, K40 is equal to 1, because it starts from 0. So these are the two cases. What is the probability that the person will either die here or here? That will be K40 less than 2. This will be K40 greater than 2. And this one, K40 is equal to 2. Okay. Now, whole life assurance policies. Suppose presently this guy is age X. In that case, this will be Kx. This is Kx plus 1. You can write this also, age line, not a problem. Just write X plus, okay. We don't need this one though, X plus Kx. Suppose x is 40 here, 40 plus, if this is 5, this will be 45. That's all. This is 5, this is 45. And we pay 1. Now we are talking about 1 unit of money payable at the end of year of death of the person who is fit and fine now. So if you find the discounted value, that will be v power kx plus 1. This is your discounted value, present value. Okay. This is your present value. So if you know present value, you should be able to find expected present value. Okay. So what is present value here? Present value is equal to v power k plus 1. K is the random variable here. Expected present value. If you find expected present value, that will be equal to e v kx plus 1. And the notation is ax here. Okay. You have to remember these expressions you are developing now. And let me write also x here. Ax is okay. Ax is the expected present value of a sum assured of 1 unit of money payable at the end of year of death of the policyholder whose present age is x. Okay. So when you find expected present value, that will be equal to v k plus 1 probability kx is equal to k. These expressions you need to remember. Okay. V k plus 1. This is p x k q x plus k from the table. You see the table. Kx is equal to k. If you see the table, you will get kx is equal to 0, 1, 2, all those. Okay. And if you want to write, you can use the other one as well. This is k deferred qx. This one also you can use. These are the two different expressions. I mean, two ways, but they are the same, not different. This is equal to this. If you expand, if you want to see, you put k0. Okay. K0. You start from k0, you get v. Px0 will be 1, you will get only q, vqx, this will be the first term, v square, px1, qx plus 1, this is the second term, v power 3, px2, qx plus 2, this is the third term, that way it will continue. That's all, you need not worry, you know already this one. Next, term assurance. Term assurance means there is a fixed term, okay? It will go this way, this is kx plus 1, where the person dies, and this is n. Up to n years only there is a validity. If the person dies here, no benefit will be paid. Okay, 0. However, if the person will die here, benefit will be paid. X plus 1, x plus 2 you can write. Okay. So same thing, present value you need to find v kx plus 1, no change. But there is a condition now. It's not fixed. Okay. I'll not write pv. There is a condition. That condition you need to write here. The condition is that the person should die before this time. Okay. Not after n. So this means kx is greater than or equal to n, right? If kx is equal to n, suppose kx is equal to n means this guy is dying between n to n plus 1. Greater than n means dying after this time. Okay. So greater than or equal to n. We'll make it sure that this will not happen. So we'll write pv v kx plus 1, but kx should be less than n. That means the person should die before n, before this term. For that you have to write kx less than n. Okay. And 0, no benefit if kx greater than or equal to n. This also you have to write. This one also you have to write. This one and this one both. However, in whole life, anytime, see, there is no limit here. In whole life, there is no limit here. Whenever this guy dies, one will be payable. So there is no limit here, but there is a limit here. So mathematically we write this way for the limit. And now EPV. Okay. The notation for this one is AXN1. This is the notation. Remember, we use only left hand side from the table. Right hand side, that is the derivation you need to know. You have to write summation v k plus 1 probability kx is equal to k. Okay. Plus the second term, if you see here, 0 will come. And here, if you see, it will not contribute k0 to up to n minus 1. Once it will start from n, there is no benefit here. Even if you want, you write only up to this n minus 1, because here it's 0 anyway. If you don't prefer, you write only this, the first one. Second one, you omit it. Okay, don't write anything. So that's all. This is the expression you need to remember. So this is actually ax plus 1. Okay, this expression when I say, that is summation vk plus 1 k double qx, you write, or pxk v q x plus k. That's all. Suppose you want to find a42 here, you apply this. No, it's n minus 1 now, not infinity. So if you put 0, k0, you get v, then px0, that is 1, q x plus 0, x is 40, and then put 2. Okay, up to n minus 1 it will go. N is 2 here, 2 minus 1, 1. So k will go from 0 to 1. For k0 you get this one, for k1 you get this. Even if you don't know this, that will be fine, but you have to know if you want to understand properly later. Okay, q41, that's all. We have two terms. If you write 2 here, we have two terms, that's all, because it goes up to n minus 1. And this is a mathematical symbol only, that's all, nothing more than that. Summation sign we use. And you put k0, you will get this one. You put k1, you will get this one. In this case, this will be summation k0 to n minus 1. N is 2 here, so that is 1. The expression. So here for k0 you will get 1, for k1 you will get 1. That's all. This is for x to n. Now the third one is pure endowment. Okay, pure endowment means on survival there is 1 here, and the discounted value will be, now if the person dies here, no benefit is here. Remember, if the person dies here, then there is no benefit. Okay, here death means no benefit. But if the person dies here, means what? What is the meaning? You need to understand a bit here. Suppose the person dies after n. Okay, present age is x here, x plus 1, x plus 2, you can write this way, up to n, this is x plus n. Now person dies here, suppose this is n is 20 and this is 40, 40 plus 20, 60. If the person dies after 20-year term, then he must have taken 1 from the company. So what was the cost for the company? The cost for the company would have been v power n. The cost of the company would have been v power n, because the person survived up to this. Company will not see, because they will give money and then there will be no connection between the company and this person. If the person survived up to this, that's fine. Whenever this person dies, after 5 years, after 10 years, after 20 years from this term, it doesn't matter, because the person survived up to this, he must have taken 1. And the cost for the company, you need to know, that is v power n. Now it's n is constant, it's not a death benefit. Okay, it's a survival benefit. So the time of the payment is fixed here.
Sir, I have a question there.
Yeah,
Can you go back to that term?
yeah, let me write it first.
Okay.
This is v power n when kx less than n, sorry, greater than or equal to n. So why not write 0? If the person dies before, there is no benefit, but if the person dies after n, then the cost for the company would have been v power n. Yeah, tell me.
Yeah, I think, I don't know whether I have overlooked that. The thing is, when at n, wouldn't his policy being played, the claim has been taken at the end, at the year end, say that is 60, you said the policy is taken at 40 and is settled at 60. So will that be payable after the completion of the year or at during that year?
What is payable?
Here at the end,
No, I got your question. You said
Ah.
that is payable. That is payable means what is payable?
the policy claim.
Policy claim will be payable
Endowment policy claim.
only here. Okay, only here.
Yes, got it. But it doesn't, we need not even have to worry, right? I mean, whether he dies or it would have already been paid.
Yeah, right. We should not worry about this. That's fine. But how can you write this expression? So when you see, when
yes.
I say if the person dies after n,
Should
then
we
I'm
really have to consider that when that doesn't hold good here? The question. Should we really have to consider if it is greater than n here?
That's what I'm asking. You tell me, what is the present value for the company if kx is greater than n?
I think it is only kx is equal to n. I don't know whether it has to be. Should that be greater than or equal to n, or should that be only equal to n?
Actually, what we are doing is we are trying to manage survival with the death random variable. Okay, that's why.
Okay.
See, I'll tell you here. Suppose this is 20 years. Okay, 40 to 60. Now, if the person dies here, zero benefit. Okay, that's here. If the person dies, zero benefit. That's here. If the person dies here, zero benefit. That's here. If the person dies here, then what is the benefit?
There's nothing. I mean to say, shouldn't that be?
No. I'm asking a question now.
Nothing. I mean,
If the person if the person dies here, okay, then what should be the benefit for this person?
That is since he has survived the 20 years.
No. You answer my question. That is 1 or 0.
That is 1.
At which point?
At 20.
Yes, that's what I'm saying. So
okay,
if the person,
just assuming we're just I got it.
When see, normally you see in insurance policies, whenever the person dies, he gets right, but the benefit will not be here because this will also come. This is called deferred assurance. That will come later. But now we're talking about survival benefit.
Okay, got it. For the sake of this one, we are
symbol for the symbol.
Yeah,
if the person, what I am saying here is, if the person,
technically, so
it's okay. That's a valid question. See, what I'm saying is, whenever the person dies, the cost for the company is only 1 here. Because the person is dying here means he must have survived till the end of the term.
Correct.
And he must have taken 1 from the company.
Yes.
Okay. And the cost that would have been definitely V power n. So it's constant term now. We will not use if the person dies here, this will be K40, this will be K40 plus 1, Kx2, Kx plus 1. But these are not important. The points are not important because in endowment assurance, this is a survival benefit.
Okay.
If the survival will happen, I mean, for the company, they will see whether the person survived till this or not. So whenever the person dies after this date, it doesn't matter because he must have taken 1 here. He must have survived till this when we say he is dying at all these points, right? So that is Vn here.
Right. Got it. Thank you.
Okay, no problem. Now, when you find EPV here, 1 is constant anyway. So the first one is 0. Will not write the first term. EPV. The derivation is not important. There is a small derivation. We'll do that later. But first one is 0. It will start from, and the second term will come here. In the term we wrote k0 to n minus 1, here n to infinity, same thing, but here it will be replaced by Vn, not Vkx plus 1. So if you expand all these things, I'm not doing that now, you will get Px and Vn. Remember, separately we'll do that. Even this is not required. We'll do that separately. You will get this one, that's all. This is the formula we used already. This is pure endowment. Now let's go to endowment policies. We have both the types. If the person survives, then we have a benefit of 1, but I should have written 1 here. Not here, and 1 here. Both the benefits are there. If the person dies, there is a benefit. If the person survives, there is a benefit. So again, you can say survives here means dying all this. That's a separate thing. We don't need. So let me write here PV. Both will come. V power kx plus 1, V power n. Let me write both here. For term, we write this way PV. PVs, if you remember, though will not use in the problems, but they will be useful. This is PV for term. This is for pure endowment PV. 0 V power n. Here you see this part is there, this part is also there, both. kx greater than or equal to n, kx less than n. That's all. And then if you take EPV, this is AXN, that will be equal to, you write both. You can say then if I write both, why it's not whole life? It's not whole life. You'll be able to know why. I'll write V power kx plus 1. Let me write the probability. The summation V kx plus 1, probability kx is equal to k, plus here if I write V power kx plus 1, probability kx is equal to k, then this will be exactly like your whole life. Okay, then I have to write ax. But when I say this is endowment, remember there is a difference. Here we don't write V kx plus 1, here V n comes, so you can't add these two. What I'm saying is, suppose if I write k 0 to 2 vk plus k 3 to 10 vk, so you can add these two. You can write one term only, vk, k 0 to 10, right? So here up to 2, here 3 to 10. But here you can't add the two terms. In endowment you don't get v kx plus 1, you get only v power n, and this term is your term AXN. This is your term, and this is pure endowment. This expression is pure endowment. We already used this one. What extra we are doing here is only the expressions. Okay, maybe sometimes you will use these expressions, but now only remember we are trying to find expressions. Okay, we already used these terms. Yeah, that's all for today's class for now. Thank you.